Here's problem 5. Solve the differential equation dy dx plus 2xy equals 2x. I will point out, this one looks like it's in the first order linear differential equation format, where you have to do like the product rule thing and all that. And while you could do that here, and you should be aware of that, I didn't see any problems like that on her final review thing, but it doesn't mean it's not fair game unless she has said it's not fair game. But instead of doing that, we should definitely see if we can try separating variables, and we can. If we isolate dy dx, it's equal to 2x minus 2xy, and we can definitely write this right-hand side as a function of x times a function of y. I can factor out the 2x. I'm left with a 1 minus y. So if you can do that, right, if you can isolate dy dx and write the other side as some things with just x's times some things with just y's, you can separate variables, and you should. So then we're going to have 1 over, let's do it this way. We're going to have 1 over 1 minus y dy equal to 2x dx. Let's integrate both sides. So the integral of 1 over 1 minus y is negative natural log of the absolute value of 1 minus y equal to the integral of 2x is x squared plus c. Now for this problem, I didn't give an initial condition, but I imagine she probably would. So let's just make one up for a second. So let's say that we have, I don't know, y of 0 is equal to, let's say 7. Now is not the time to solve for our constant. I'll show you when. So let's multiply both sides by -1, and we're also just going to drop the absolute value. I promise you it will work out. So we have the natural log of 1 minus y equal to negative x squared. You could say minus c. I'm going to say plus c. Or if you want, I'll say plus c1 to indicate that this c1 is different than that c. But essentially, right, the negatives. Then we're going to exponentiate both sides. So e to the natural log of 1 minus y equals e to the negative x squared plus c1. This right side, we always separate this out. So this is going to be 1 minus y equals e to the negative x squared times e to the c1. And then this becomes a new constant, which I'll call c2. I think she usually calls it k. Doesn't really matter. So 1 minus y equals k e to the negative x squared. And pretty much here is the time where it's probably good to solve for your constant. So if I plug in 0 for x and 7 for y, you get 1 minus 7 equals k times e to the 0. That's 1, so k equals -6. And then we can solve for y. So 1 minus y equals -6 e to the negative x squared. Adding y here, adding 6 e to the negative x squared there, you get 1 plus 6 e to the negative x squared equals y. And we can see that if you plug in 0 for x, you do get 1 plus 6 equal to 7 for y. So yeah, that's it. That's problem 5.